Like, subscribe, and share. Hello, welcome back to school. After this coronavirus pandemic, we welcome all our students back on campus. Today, we are going to learn about sets. So if you are in first year, you have to know how sets and numbers work because we are going to use it in numerous ways. Okay, so welcome back. Let's know what sets are and how to solve sets. When we say set, what does it mean? A set is a collection or list of objects, quantities, or numbers with specified properties. So you see, we have a set of 4 pink boxes. And the figure at the right is also a set of 12 yellow boxes. So with this, we can have so many things that can be quantified with sets. Examples: a set of books or a set of numbers. Let's look at some definitions that will help us to define the elements of sets in the problems. First, we shall look at what an odd number is, and then an even number. Okay, what is an odd number? An odd number is a number which, when divided by 2, leaves a remainder of 1. So you think of a number which, when you divide it by 2, you will get a remainder of 1. So let's see some examples. So examples of some odd numbers, you have -5, -3, -1, 1, 3. So let's look at what an even number is. An even number is a number which leaves no remainder behind when you divide it by 2. Yes, any number when you divide it by 2 and if there is no remainder left, that is an even number. So examples of some even numbers, we have -6, -4, -2, 0, 2, 4, 6, and so on and so forth. Now, let's look at what an integer is. An integer x is said to be a factor of another integer y if x can divide y without leaving any remainder. Example: the set factors of 48 are 1, 2, 4, 6, 8, 12, 24, and 48. These numbers can divide 48 without a remainder. So these numbers are integers of 48. So now let's look at what a prime number is. A prime number is any positive number that is exactly divisible only by itself and 1. Example: 2, 3, 5, 7, 11, 13, 17, etc. Meaning, no number can divide a prime number except the number itself and the number 1. So you see, 2 can divide 2 and 1 also can divide 2. 3 can divide itself 3 and 1 can also divide 3. 5 can divide 5 by itself and 1 also can divide 5. 7 can divide 7 by itself and 1 also can divide 7. 11 can divide itself by 11 and 1 also. 13 the same thing, and 17. So you see, 2 cannot exactly divide 3. Neither 3 can divide 5 exactly, nor 5 divide 7 exactly. You see, there shall always be a remainder. But you see, 2 can divide itself, 3 can divide itself, 5 can divide itself, and 7 can divide itself. So in conclusion, no number can divide a prime number except the number itself, or the number 1. Now, let's look at prime factors of a number. When we say prime factors of a number, what does it mean? This simply means that the factors of a number that are prime numbers. So now that we have learned some definitions, get your pen and paper and let's solve these examples. List the elements of the following set and determine the number of elements of each set. Set A. X is such that X is a multiple of 3 less than 81. B. X is said that X is a factor of 72. And C. X is such that X is an even number between 5 and 21. Now let's see the solution. Set A. X is said that X is a multiple of 3 less than 18. So if X is a multiple of 3 and at the same time X is less than 18, you will get numbers like, or you will get integers like 3, 6, 9, 12, and 15, which are all less than 18. For set B, we have X is said that X is a factor of 72. So now if X is a factor of 72, you will get 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. So you see, all these numbers can divide 72 without a remainder. So we can say these numbers are factors of 72. Now let's look at set C. For set C, X is said that X is an even number between 5 and 21. So if you want even numbers between 5 and 21, you will get 6, 8, 10, 12, 14, 16, 18, and 20. These numbers are the even numbers that exist between 5 and 21. So now let's look at the set PQR. For P we have X is such that X is greater or equal to 3, and at the same time X is less or equal to 12, where X is the integer. So for this, it means that all the numbers that will fall within 3 and 12 are X. So for Q we have X is such that X is greater than 6, at the same time X is less than 12, where X is the integer means all the numbers that are greater than 6 but less than 12 are what X stands for. And for R we have X is said that X is greater than -2, at the same time X is less or equal to 3, where X is the integer. This means that all the numbers that are greater than -2 but less or equal to 3 is what X stands for. So for set P we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the numbers that are greater or equal to 3 and at the same time less or equal to 12. Okay, then let's look at set Q. For set Q we have 7, 8, 9, 10, and 11. Meaning these are the numbers that are greater than 6 but less than 12. Then finally, let's look at set R. For set R we have -1, 0, 1, 2, and 3. These are the numbers that are greater than -2, at the same time less or equal to 3. Now that you understand today's lesson, try your hands on set XYZ. For set X, we have X is said that X is a prime number less than 15. And for set Y, we have X is such that X is an even number less than 15. And for Z, we have X is such that X is an odd number less than 15. So try your hands on these numbers as we call it a day. Thank you for joining us today, and get prepared for the next lesson next time. Make sure you like, subscribe, and share.